Good everyone, my name is Graphics. In this video, we want to solve a problem involving interpenetration of surfaces, right? Or will I say interpenetration of solids, whereby a prism is intersecting what? A prism. And the question goes like this. It says a square prism base 50 millimeter side and 80 millimeter long is resting vertically on HP. It is penetrated by a triangular prism of 44 millimeter side and 100 millimeter length, so that their axes intersect each other at right angle. If the faces of the square prism are equally inclined to VP, that is vertical plane, and one of the rectangular faces of the triangular prism is parallel to HP, draw the projection of the solids showing lines of intersection. Now, as you can see the question on the right hand side of the screen, we're going to interpret it. What is all these grammars? Now, what is making us understand that we have two types of prism here. We have the square prism, right? And we also have what is called the triangular prism. Now, the triangular prism is penetrating, right? Is piercing the square prism completely. Is that taken? It's piercing the square prism completely. So we are told that we should draw the curve of intersection, and also we should show this on diagram, right? So the first thing we'll do is to draw our horizontal line this way. So again, we should draw our horizontal line this way, and we'll also draw our vertical line also this way. So I'll take my other meter rule, place it on my set square, and I'll draw another vertical line. Is that okay? Now, if you look closely, we are told we are not given the length of the square prism, right? We're only told that the square base is 50 millimeter, is 80 millimeter, 50 millimeter side and 80 millimeter long. So the side is given, but the entire length is not given. Because of that fact, we're going to start drawing from the plan, so we know the actual length of what of the square base, right? So what I'll simply do here is to take some important notes here. In terms of the square, we are told that all the sides of the square is 50 millimeter, and we're also told that the square prism, you see where I'm underlining, the square prism are equally inclined to VP. So it means that the square prism is what is inclined to what? To VP. Is that okay now? So this is my VP, my horizontal plane, and the square is what? Is inclined to what? To VP. So what I'll simply do here is to draw another line, just a center line, not really much. Just draw another line this way. You see what I want to do? I'll just draw another line this way. Ignore this one you've done here. Just draw another line this way. You can see the line at this point where they meet. Now take your 45-degree set square, because you know a square, it has 90 degrees, and diagonal of the square is what? 45. So I can draw the diagonal of the square, assuming that this I'm drawing at an angle of 45 degrees is the diagonal of the square. So I'll just put it this way. Now you can see that. So this is the diagonal of the square, and it said each side is what? Is 50. So we'll take the diagonal of the square as my center line, right? So I'll take my 0 as the middle line here, and I'll start moving that 0 until I get to 50. As you can see, So where's my 50 here? This is my 50 here. You can see what I'm doing. 0 is my midpoint. You can use any meter rule, and I'm ensuring that I'm having what I want to have here. You can see that. So this is 25 here, and this is another 25 here. From 0 to 25, from 0 to 25, that is 50. So I'll just thicken it from this point straight down here. You can see that. Now this is what I just need. If you calculate it, if you measure it from here, this is what? From 0 to 50. You can see that. That is the aim. Now in doing that, I will now take my compass, right? And I'll place it at the center point here. And I'll take it to this point, right? So from this point, let me adjust it well. I'll move it up and I'll move it to the left. Is that the king? Or if I can't do that, just take it to this diagonal here and place it somewhere around there, any of the two. So what I will do is I'll join those points together. So from here to this point, this is 50, and also from here to here, this is another 50. So this is another 50 here. And this is another 50 here. Hope you can see that. So this is what is telling us. This is each side 50, and they are inclining at the VP. This is my vertical line, they're inclining at the VP. Now we're not told that the square pyramid, the triangular pyramid is piercing this square pyramid completely, and the length of it is what is given to be 100 mm length. You can see where my R is aligning, and the thickness is 44. So what I will just do is I'll take my meter rule, right? I'm going to take my meter rule and I'll measure half of 100, which will give me 50. Hope you can see that. And I'll come to the midline here, and I'm going to mark center line here. I'll mark 50 to the left and also 50 to the right. You can see that. Now I'll take my set square in this fashion, and I'll draw the vertical line. Is that okay? And I'll draw the vertical line just a little bit. Now come here, also draw another vertical line just a little bit. You can see that. And we're told that the thickness, you can see it says we have 44 mm here. You can see that the triangular prism of 44 mm side. So each side is 44. So I'll measure one of the side, which is what 44. So I'll take half of it also, which is 22. From 0 to 22. Can you see that? From 0 to 22. And I'll place it at this point. I'll mark up and I'll mark down. So what is important is I'm going to draw this from this point, right? And I'm going to thicken this to meet here. Also from here, thicken this to meet here. Then I'll come here also. I'll do the same thing from here, thicken this to meet here. Also from here, thicken this to meet here. You can see that. And I will take my meter rule. I'm going to close it up. Right, I'll come here also. I'm going to close it up too. You can see that. Let me make this more visible. Right. So as you can see that this is the plan. that we've considered, we've drawn out. Now let's now see how we can bring out the elevation. Is that taken? Now we'll still focus on, first of all, start by drawing the horizontal plane this way. This way. I can just give a height of 10 millimeter away from here, from 0 here to 10. I have the reason from 0 here to 10, right? Then I'll just draw an horizontal line this way. You can see that. Now we're told that from the beginning, we're talking about the square now, we're focusing on the square now. So the square prism base is what? 50 millimeter and 50 millimeter side, right? So now we already gotten the plan. They already give us the side, not the entire distance of it. So from here to here now represent the base, right? From here to here represent what? The base. So what I will just do is I'm going to project the square prism here upward, and I'll project this also upward. So meaning that from this point to this point is the base of the square pyramid. We're only given the side, so we use to draw what? The base. And we're told that the length, it is 80 millimeter long. So meaning the height is what? 80 millimeter. So I'm going to measure 80 millimeter, starting from 0 to 8 here is 80 millimeter. Hope you can see that, right? 80 millimeter. And I am going to what? Close it up. I'll do what? I'll close it up at this point. You can see that. And the center one here also, which is this point, I'll draw a line that will close it up too. You can see that. So we'll get to this. Since we're not given the actual distance, so we'll take half of it, which is what? 40. So I'll measure 40 millimeter upward. This is 40. Then I'm going to draw an horizontal line this way. I have my reason. You can see the horizontal line that I'm drawing now, and I'll take this up also. This way, and this up also this way. That is for the triangular prism. Now the next thing that I'm going to be doing here is this. I'll just draw a line close to it, another line close to it this way, very close to it, and this is where it is actually meeting. Is that taken? That is where it is what? Actually meeting. So what I will do, I can just give it a space, more space. Let me give it more space. Now you draw a line, right? 22 millimeter. Let me see, 30 millimeter away from this line. Just draw a line 30 millimeter away from this line. This is the line I am drawing here. Is that taken? Now the key word is it is a triangle, and the sum of angle in triangle is what? 180, right? That means each of the axes are 60 millimeter away from each other, right? 60 degree away from what? Each other. So when I place my center point here, this point I have here, to align with those my vertical and horizontal line this way, you can see that. So this is the 90-degree line here. Hope you can see that. The 90-degree line here, the 90-degree line. So from 0, this is 0, 10, 20, 30, 40, 50, 60. This is another 0, 10, 20, 30, 40, 50, 60. Hope you can see that. I'll just draw from each of these points towards the center like this. Just a little bit here this way. Taking this as my reference point to the center. I'll come here also from here. Taking this as my reference point to the center. You can see that. Hope you can see that. Now what I will do, let me extend it a little bit. Let me extend it a little bit. Now what I will do is, we're told that the thickness here of the triangular prism is 44, right? So what I'll just do here is, I'm going to measure 22 each. So from 0, this is 22 here, right? This is 22 there, and this is another 22 here. So if I should take them down a little bit this way, just down from here to touch this inclined line. I'll come here also to draw a line to touch this inclined line. You can see that faint line. That means the thickness from here to here is what we need. So this is my 44, right? But I don't actually need to draw everything all together. So what I'll just do is, I will not take the distance from here to here, 44, right? And I'll place it here. I'll strike an arc, and also place it here. I'll strike another arc. So where they meet, this is what I need here, just from here to this point. I just need half of it, not everything. This is what I just need. It's supposed to be a faint line to this point. Right? I need a faint line. Let me just make it more visible. Faint here this way. I don't really need it. So let me dim this. This is what we have here. I only need this. I don't want to draw it completely. Remember? So I'll call it to be 1. Here to be, let's say, here should be 1. Here to be 2. And this point here to be what? 3. You can see that? Just like we will do initially. So I should be able to project this point straight down here. From here, I'll project it in to come and touch the other end. Then from here also, I'll project it in to come and touch the other end. So since here is 3, I will now switch it here. So let me bring this down also from this point. That taken from here. All together. So what I will do is, in this case, it is facing up, but now it will be facing the other way around. So I can just from here, what I want to do, from this point, we have the same length, 44. And here also, the same thing too. You can see that. And here I'll just take half of it. I don't need the full of it. Anyway you want to start with, we'll just have this from here to here. Just any one. Right? Then here will be, let's say we'll call it 1 and what? And 2. That is the entire length here. Right? So let me just complete it here to get to understand what I'm doing. So here, I'll do the same thing too. Take the height from this point, which is the same thing here. I'll place it here and just mark. Or you just from here, place it here, and you just need the height from the base to the top here. Can see that? So I'll just join it this way. So what do you notice? The height here will now become 3, right? Here will become 1, and here will become what? 2. Just like here is 1 and here is 2. Is that taken? So now let's see what will happen. Now, after projecting this inward this way, what I'll just do is I'll start projecting my lines. If I move this from here upward, what do you notice? 2 and 1 are on the same point, and this is 2 and 1, they are meeting here. So this is my 2, comma 1. Can you see that? Similarly, this is the line of 3, is where 3 is, and where 3 meets 3 is at this point here. This is where 3 meets what? Meet 3. So I'll just join it together from this point, straight down here, and where it meets with this line, that's where I'm going to stop. From here, straight down here, and from here, straight down here, and I am going to close it up. Can you see that? And I'll close it up too. And I'll close it up too. Is that taken? And I will come here too. I'll do the same thing. So let's see what is happening. This is 2, right? On this point. This is the line of 3. 3 is coming here. 3 meet 3 here, right? Then 1 and 2, 1 and 2 are on the same point here. 2 and 1. So when I take them up from this point, 2 and 1 is meeting on this line here. So this is still my 2, comma 1. So it's all the same thing, and I'm going to join from here to here. Then I'll take it out from here to here. And I'll take it out from here to here. Then from here to here. Then I'll close it up from this point to this point. Then from here to here. Hope you can see what I'm actually doing here. Right? You can see what I'm trying to do here. So I have successfully reproduced this figure. This is the plan. So if I'm to do dimension, but before we move forward, we need to understand something. If we are now told to draw the end elevation, this is the front elevation, this is the plan, right? Now we're not told to draw the end elevation. And before I draw the end elevation, let me draw out the dimension that we have here. So we have from here, it says the triangular prism is penetrating the square prism completely, and the length of it is given there to be 100. Hope you can see that statement there where my arrow is, my line is covering. So this is from here to here is what? 100 millimeter, right? And the square prism, the sides of the square prism here, each of these sides from this point to this point, right? Let's just come out a little bit. So we have let me just put it here. Is that taken? So the square prism from this point to this point, from this point to this point, is given to be, put this, and that is what? 50 side each, right? Then the what else again is given? The height of this is given to be 80. So from here, I'll just take it up to this point, to here, and also to here, to the thickness, the height, which is still long. You can see where my lines are aligning on the diagram, given to be what? 80. Can you see that? So this is what we are actually given. The length of the triangular prism 100, the height of it 50, and each side is what? 50, right? The height of it 80, and each side of it is what? Is 50. Is that taken? And while they are standing, the questioner says it is perpendicular, right? Since both of them are penetrating each other perpendicularly. So that keyword perpendicular means that what they are coming together at what the axis are 90 degrees to each other. So if this is the center line of this and the center line of this, they are forming what? An angle of what? 90 degrees to each other. So let's move forward. Now let's now assume, or the questioner suggests that we should draw the plan. This is the plan, the front elevation, and also what the end view. So what would the end view look like? So close to it here, I might just get a center line here. Let me see. Since from here to here I use 10, so let me say half of it is 5. Right? Any line you can just draw, no big deal there. You can just draw any line from there. So I just draw a line this way. Alright? And I will draw another line this way here. Close to it this way. You can see that. So once I've done that, I'll just draw another 45 degree, place it on a T-square this way. And you draw a 45 degree like this. So let us start with the square prism first. So if I start with the square prism, because that is what is penetrated, this will come up to touch this, and this also will come up to touch this. So this is where it's touching. So let me extend this way. Let me extend this too, so we'll get to where they are meeting. And I'm going to take that up from this point where it meets. I'll take it up vertically. I'll come here also. I'll take it up here too vertically. You are taking. So to get it, look at this. You're same doing with the square prism. So if I project this to this point, so they are meeting here, so I can easily take in from here to here. I'll come here also, square prism. I'll move this line from this point to this point, and also take in here this way. You can see that. And I'll also take in the sides too, from here to here. So from here to here. And from here to here. That is the square prism. Now, looking at it from the front, now we're looking at it from this side here or this side. So if I do that, I can get the center of it. Just come from here, just project this way, the top here, and the top here. So we have 2 and what? 1 and 2. So let me project 1 and 2 this way. This is 1, and this is what? This is 2. You can see that. And when I take it up from here, I have this, and I have this. So this is where 1 and 2 meet. 1 and 2 meet both at this point and this point. So we have 2, we have 1. So I'm going to what? I'm going to take in it from this point straight down to this point here. You can see that. And from this point, before that, they'll move forward. Then the next one is 3. So if I project the line of 3, this is the line of 3 I'm projecting to this point. And I also project this point upward this way. Right? And let me make it more visible so you can see what I'm saying. So this is the line of 3 going up. So let's project the line of 3 also. So this is where 3 is meeting what? 3. So when I place it this way, I can easily take in it in this direction. Can see that? Hope you can see that, right? So that is when you are looking the prism from the front, this side. So this is what you'll be seeing. So this is the front elevation. This is the plan, and this is what the end view of and we're not even done yet. So at this point here, I'm going to draw this to this point and this to this point. Because of the sharp edge, you're going to be seeing it, right? Looking at this point here. So this is what we have here. This is the intersection of a square prism surface and a triangular prism surface. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.